Hello friends, today we start our syllabus of chemistry for the semester first. So we start here chapter first, chemical energetics of subject CH101 physical chemistry. Okay, chemical energetic. Now we discuss first point is thermodynamics. Okay, so what is mean by thermodynamics? Thermodynamic means, thermo means, what is thermo means? Heat. Thermal word is totally associated with the heat energy. Okay, so this is the heat. So first we write here thermo means heat, and dynamic means what? Mechanical work. So simply we can split this word into the two small words. Thermo means heat, and dynamic means mechanical work. So thermodynamic means the heat can be used into the mechanical work. Okay, so simply we write here its definition. Definition of thermodynamic. This is the branch of science which deals with the study of quantitative relationship between heat and other forms of energies. Okay, so right here, this is the branch of science which deals with what is it? It means branch of science which deals with the study of quantitative relationships between heat and other form of energies. So this is one of the simple definition of thermodynamic. Branch of science which deals with, so this is the branch of science which deals with the study of, what is the study? What type of study here? Quantitative relationship. Quantitative means quantity. Quantitative relationship between heat and other forms of energies. Okay, so this is one of the simple definition. Remember student, laws of thermodynamics. So what are the laws of thermodynamics? Laws of thermodynamics. So what are the laws? This is first law, second law, third law, Zeroth law, etc. You can discuss about these laws in this chapter. Then objectives. What are the objectives of thermodynamics? What are the objectives? Here, first objective is to predict the feasibility of a process. First objective, to predict the feasibility of the process. Feasibility of the process. Okay. If you can carry out any process, either that process is run or not can be determined by the thermodynamic. The next one, to estimate the yield of the product. Second one, to estimate the yield of the product. Yield of the product. In this case, this is one of the very important objective. To estimate the yield of the product means if you have carried out one reaction and in that reaction you get a product. So what is the yield of that reaction? Means what? The starting material and the product. What are the composition, product composition and reactant composition? In this case, here we can determine very easily by using thermodynamic concepts and thermodynamic conditions. We can find out the amount or yield of your product, either that yield is 70%, 90%, 95% and so on. Okay. So and the third and last objective is to deduce some important relationships. To deduce some important relationships. Okay. So in this case we see here, to deduce you can find out what is the connection between the two reactants, how they can convert into the products, and it can very easily we can find out by using thermodynamic concepts. So this is the important form or important objective, to deduce some important relationships between chemical changes. Okay. So these are some simple objectives. The next one, limitations of thermodynamic. After objective we can see the important point, which is limitations. Thermodynamics. So listen student, when we learn any concept, at that time there are two sides of coins, pros and cons. So here these are some objectives are concluded in the pros and limitations are the cons. So some limitations of thermodynamics are also here. There are three limitations. First, which can deals with the properties like temperature, pressure, etc. of the matter in the bulk macroscopic quantities. Okay. First, deals only with macroscopic particles and not with microscopic particles. Okay, suppose we can study the properties like pressure, temperature, volume. These are some thermodynamic properties, and when we discuss that properties, at that time we can only use that properties for the macroscopic particles and macroscopic substances, and not for the not with microscopic particles. This is one of the limitation. Then another limitation is it helps to predict the feasibility of a process but give no idea about the time taken for the process. Okay, it doesn't give any idea about time span taken for completion. Okay, in this case we can show here, suppose we see here, this is one of the limitation, and we can discuss earlier first objective to predict the feasibility of the process. Here we can predict that feasibility of any change, chemical change into the thermodynamic way, like temperature, pressure, volume, heat, energy change also. This is one of the thermodynamic property, but we doesn't give any idea about the time consumed to convert that one form into the another form. So this is one of the limitation. And the last limitation is its treatment is limited to the initial and final state of the system and is silent about the path by which the change is carried out. Okay, this is the third limitation. The thermodynamic properties are limited to the initial and final state of the system only. Okay, and these properties are not give any idea about the path through which that change is carried out. Okay, suppose we take a simple example. Suppose we want to go from A position to the B position. Okay, suppose this is one of the A point and this one is the B point. At that time we are only consider the initial. Suppose this is the initial state and this is the final state. Okay, and we are only consider these two states and not through which we can reach to this point from this point. Okay, suppose we go through this way. This is one of the first way I reach from A to B. This is first way. This one is the second way, and this one is the third way. I reach to the B from A, and these are the path. First, second and third. But we doesn't any meaning, or we can't find what path we chosen for the transformation or for reaching towards B from the spot A in thermodynamic. We doesn't able to find out its path, and we can only stay with the initial and final state of the system. Okay, thank you.